Hello students, once again welcome you to GK's maths classes. Today what we are going to do is, in continuation of applications of differentiation, we are going to do increasing and decreasing function. Mostly this will be the concluding video on increasing and decreasing function. Today what we are going to do is, we are going to do problems where it involves more or less proving type of questions. Okay, so let's straight away get inside. First of all, a quick introduction to increasing and decreasing function. I say the function y equal to f of x is increasing. When do I say it's increasing? When your derivative is positive. Okay. You say the function y equal to f of x is decreasing when you know that dy by dx is less than or equal to 0. If it is greater than 0, you can say strictly increasing. Less than 0 means strictly decreasing. And the graph of an increasing function will be like this. And the graph of a decreasing function will be like this. I have given in detail the explanation for increasing and decreasing function in part 1 of application of differentiation, which I will put in the description box. In case you have a doubt, you can always refer to that. Okay. So I don't want to waste my time once again and giving you introduction on increasing and decreasing function. Let's start with this is a continuation of what we have done in part 3. In part 2 and part 1, part 2, part 3, we have done problems like find the interval in which the function is increasing or decreasing. But whereas here we are going to prove. Here you see, the prove that the function is increasing in R. That means it has to be increasing at every point in R. Let's see how to go about it. So first of all, I'll take my f of x, that is f of x is equal to x cube minus 6x square plus 12x minus 18. And then I find dy by dx. So what is dy by dx? It is 3x square minus 12x plus 12. 3x square minus 12x plus 12. Now what do you do? No need to equate it to 0. Instead what I do, I take common. What do I get? X square minus 4x plus 4, which is nothing but 3 into x minus 2 the whole square. And you know, 3 into x minus 2 whole square is always positive. In fact, it will be equal to 0 when x is 2. Okay. Therefore, can I say the function is increasing? It is not strictly increasing. The function is increasing in all real numbers. Suppose if they ask you to find for strictly increasing, you can say the function is strictly increasing for all real numbers except 2. Okay. I hope it's clear to you. Okay. Now let's try to solve this problem using GeoGebra also. Just let's have a look at it. Okay. And the next question. Now here the function is y equal to 3x power 5 plus 40x cube plus 240x. I have to show it is increasing in R. It's something similar to the previous problem. So what is dy by dx? So dy by dx will be 15x power 4 plus 120x square plus 240. Okay. So now what I will do, I will try to take 15 outside. 15x square is common. So what do I get inside? I will get x square plus, so how many times will 15 go? 4s are 20. This is 6, 30. 15 8s are 120. So it goes 8 times. 8x. So I took x square out, right? No, I can't take x square out. I'm sorry. I took 15 outside, so I get x square, x power 4 plus 8x square plus, what is 240? 240 is 16. So which is nothing but 15 into x square plus 4 the whole square. This is always positive. It can never be 0. Therefore you can say the function is strictly increasing. In this case you can say strictly increasing in the entire real line. The function is strictly increasing in the entire real line. So first I took x power 4, or no, nothing is common. So only 15 is common. So you got this. Okay. So let's try this on GeoGebra and see what it is. It will be 3x power 5. Okay, let's go to the next question. Prove that the function x square minus x plus 1 is neither increasing nor decreasing. So what I will do? First I will find dy by dx. What is dy by dx? Dy by dx will be 2x minus 1. Then what I do? I equate it to 0. So when I equate it to 0, I get two values of x. I get x is equal to 1 by 2. Then what I do? I break the interval. Now what will be the interval? Minus 1 comma half, because it is only from minus 1 to 1. And then I have half comma 1. What I do? I choose a number between minus 1 and half. I will choose 0. And check what happens to my dy by dx. So my dy by dx will be 0 minus 1. It's negative. Therefore the function is strictly decreasing in minus 1 comma half. Wonderful. Now what I do? I choose a number between half and 1. When I choose a number between half and 1, I'll choose 3 by 4. So what happens to dy by dx? Dy by dx will be 2 into 3 by 4 minus 1, which is 3 by 2 minus 1, which is positive. Therefore the function is strictly increasing in half comma 1. Now what is the problem here? The problem is I have the interval say minus 1 to 1. Now minus 1 to half, the function is decreasing. I use the symbol for decreasing. And then from this region, it is decreasing, correct? And then from half to 1, the function is increasing. So when I look at it from minus 1 to 1, some part of it is decreasing, some part of it is increasing. So I can say the function is neither increasing nor decreasing in minus 1 comma 1. Suppose, let us assume that suppose for half comma 1, if it was decreasing, suppose for half comma 1 it was decreasing, and then I can say from minus 1 to 1 it is decreasing, because this is decreasing, this is decreasing. Or if this has been increasing, I can say minus 1 to 1 it is increasing, but partly it is decreasing and partly it is increasing. So I can conclude that the function is neither increasing nor decreasing. Clear? We'll just test this on GeoGebra and see how the graph looks like. Let's see how we go about it. If minus 1 less than x less than 1, okay, what is the function? X square minus x plus 1. So this is the graph. You see, some part of it is decreasing, some part of it is increasing. You see, from here, you see, from here to here it is decreasing, and then it is increasing. So the function is neither increasing nor decreasing. From minus 1, I think this is half. From minus 1 to half, it's decreasing. And then from half to 1, it is increasing. So I can say the function is neither increasing nor decreasing. Okay, let's go to the next problem. Now, I is an interval disjoint from minus 1 comma 1. That means what? I is an interval disjoint from, that means minus 1 comma 1 is removed from it. From the entire real line, I am removing minus 1 comma 1. So what is effectively I? I is nothing but minus infinity comma minus 1 union 1 comma infinity. Remember, minus 1 and 1 is not included because it is there in the closed interval. Now I have to show in this interval the function is increasing. Let's see how. I have the function y equal to x plus 1 by x. Now you differentiate dy by dx. What is differentiation of x? Differentiation of x is 1. 1 by x is minus 1 by x square. Okay. Now what I do, I choose a number between minus infinity and minus 1. The number will be, say, minus 2. And I substitute here. So what do I get? Dy by dx is equal to 1 minus 1 by 4, which is obviously positive. So I can say the function is in fact strictly increasing in minus infinity comma minus 1. Now what I do, I choose a number between 1 and infinity. Again I choose, say, 2. Now what happens to dy by dx? My dy by dx will be 1 minus 1 by 4, because x is 2, so x square will be 4. Again this is positive, so I can say the function is strictly increasing in 1 comma infinity. So what have we proved? Therefore the function is strictly increasing in minus infinity comma minus 1 union 1 comma infinity, which is for me is I. Isn't it? Very, very simple problem. Okay. So you want to see it on GeoGebra, we can just test it and see. I think it's going to be a bit complicated. I'll give it a try. Now I have to prove that this function is increasing in 0 to pi by 2 and decreasing in pi by 2 comma pi. So y equal to log of sin x. So what is dy by dx? Dy by dx will be 1 by sin x into cos x. So dy by dx is what? Dy by dx is cot x. And you know, cot is always positive in the first quadrant. Therefore, the function is strictly increasing in 0 comma pi by 2. And also you know that dy by dx is equal to cot x will be strictly less than 0 for pi by 2 comma pi. Which quadrant? This is second quadrant. In the second quadrant, cot is always negative. So you can say the function is strictly decreasing in pi by 2 comma pi. It's a very, very simple way of solving the problem. Very important question. It's an NCERT question also. And let's go to the next question. Here I have got y equal to log of cos x. Okay. The modulus is put, basically no need to put modulus because 0 to pi by 2 cos is positive. 3 pi by 2 2 pi, that is fourth quadrant, cos is positive. So it makes no sense to put modulus. So what is dy by dx? Dy by dx is 1 by cos x, and differentiation of cos x is minus sin x. Differentiation of cos x is minus sin x. Now what is this? This is nothing but minus tan x. Okay. Now clearly in the first quadrant, tan x is positive. Tan x is positive when x belongs to 0 to pi by 2. First quadrant, tan is positive. In the first quadrant, when tan is positive, minus tan x will be negative, right? And this is the reason. Minus tan x will be negative. Therefore, I can say the function is strictly decreasing in 0 comma pi by 2. Now if you go to 3 pi by 2, if you go to 3 pi by 2 comma 2 pi, definitely tan x is negative. Why? In the fourth quadrant, tan is negative. If tan is negative, your dy by dx is equal to minus tan x will always be positive. So I can say the function is strictly increasing in 3 pi by 2 comma 2 pi. Very, very simple question. Straightforward, simple problem, isn't it? Now let's go to the next problem. Which of the all these are NCERT questions. Which of the following functions are decreasing in 0 comma pi by 2? Okay. Now first I'll take A. I have got y equal to cos x. Now what is differentiation of cos x? My differentiation of cos x will be minus sin x. Obviously, sin x is positive when x belongs to first quadrant, 0 to pi by 2. When x belongs to 0 to pi by 2. So obviously, dy by dx equal to minus sin x is negative, because sin x is positive, minus sin x is going to be negative. So I can say the function is strictly decreasing in 0 comma pi by 2. So this is strictly decreasing. Now let's go to the next one. The B part is y equal to cos x, cos 2x. Now what is dy by dx? Dy by dx will be minus sin 2x, and differentiation of 2x is 2. Okay. So can I say this is minus 4 sin x cos x? What did I do here? I wrote sin 2x as 2 sin x cos x. I wrote sin 2x as 2 sin x cos x. So it is minus 4 sin x cos x. Now in 0 to pi by 2, clearly sin x and cos x are both positive. Sin x and cos x are both positive. Okay. Therefore, when x belongs to 0 to pi by 2, it's always positive. In the first quadrant, sin and cos are positive. So obviously this is negative. So this implies the function y equal to cos 2x is strictly decreasing in 0 comma pi by 2. Or you can say decreasing in 0 comma pi by 2. In fact, it is strictly decreasing. Now C, y equal to cos 3x. Well, I will not do this part. Please refer to part 3 of the video. I have done the same question, okay, where some part of it is increasing and some part of it is decreasing. So this is neither increasing nor decreasing in 0 to pi by 2. Okay, this is neither increasing nor decreasing in 0 to pi by 2. Okay, therefore it's not decreasing. So this is correct, whereas this is not correct. Okay, to know the complete proof, please refer to part 3. I don't want to waste my time with this. Okay, now let's go to the last problem. Y equal to tan x. What is differentiation of tan x? Differentiation of tan x is secant square x, which is obviously positive for x belongs to 0 to pi by 2. So since it is positive, it is an increasing function. So I can say the function is not decreasing in 0 comma pi by 2. Okay. That's what he's asking, right? So this is not decreasing. So these two are decreasing function, whereas these two are not decreasing function. This is in fact increasing, whereas this is neither increasing nor decreasing in 0 to pi by 2. Okay. Very, very interesting problems. So this is again a very, very important question. Previously, which of the following functions, interval is given, which of the following functions are increasing and decreasing? Here, a function is given, you have to check in which of the following interval is the function increasing or decreasing. Okay, let us, it's slightly lengthy, we'll do it a little slowly. Now, first of all, I'll take the function x power 100 plus sin x minus 1. Now what do? You differentiate this. What is dy by dx? Dy by dx is 100 x power 99 plus cos x. 100 x power 99 plus cos x. So now what is the first interval? First interval is 0 to pi by 2. 0 to pi by 2, cos x is always positive. It lies between 0 and 1. So in 0 to pi by 2, cos x is always positive. It lies between 0 and 1. Okay, and 0 to pi by 2 is nothing but 0 comma 3.14 divided by 2. Pi by 2 is this, right? Which is 0 comma 1.57. Therefore, x is always positive. So when x is from 0 to 3 pi by 2, it's always positive. X is also positive. 0 to 1.57 is always positive. Therefore, 100 x power 99 will always be positive. Because x is positive means 100 into x power 99 will be positive. And you already know cos x is positive. Therefore, can I say dy by dx will be positive? Therefore, the function is increasing. Question is what? Function is which of the following interval is the function increasing? Okay, that's the question. Function is increasing in 0 comma 1. Sorry, 0 comma pi by 2. Very simple. First part is over. Now let's go to the second subdivision. What is my second subdivision? Second subdivision is x belongs to pi by 2 comma pi. X belongs to pi by 2 comma pi. That means second quadrant cos is always negative. But it is not a huge negative number. It is a very, very small negative number from where to where? From -1 to 0. Because in the second quadrant cos is negative. So cos will always lie between -1 and 0, but it is a very, very small negative number, not a huge negative number. It's a small negative number. Now x belongs to pi by 2 comma pi. Pi by 2 is nothing but 1.57 and pi is nothing but 3.14. So obviously x is not only positive, it is more than 1 also. It's a number which is more than 1. If it is less than 1, something to worry about. But x is more than 1. When it is more than 1, 100 x power 99 is going to be a big number. It won't be a small number. Suppose if x is less than 1, any power of x will be small. But when x is more than 1, x power 99 is going to be a huge number. So 100 into x power 99 will definitely be greater than cos x. Even though cos x is negative, a small negative number added to a very big positive number. This is a small negative number and this is a big positive number. So when I add, obviously dy by dx is going to be positive. This will be 100 x power 99 plus cos x will be positive because cos x is negative, but 100 x power 99 is a big positive number. A big positive number plus a small negative number will be a positive number. Therefore, you can say the function is increasing in pi by 2 comma pi. The second part is over. Now what's the third subdivision? Third subdivision is, I'm talking about 0 comma 1. I'm talking about 0 comma 1. Then 0 comma 1, x belongs to 0 comma 1. 100 x power 99 is always positive. 100 x power 99, because x is positive. X is positive, 100 x power 99 will be positive. It's a very small positive number, not a very big positive number. Now, 0 comma, what is 1? It's in radian. Okay, if I have to use it as a radian, you know 180 degrees is pi radian. So 1 radian equal to 180 degrees by pi. Correct? Therefore, which is 180 degrees divided by 22 by 7, which is approximately, I think it is 57 degrees, approximately, okay? So it is 57 degrees. So 0 to 57 is in the first quadrant. In the first quadrant, cos x is always positive. Cos x is always positive. Therefore, my dy by dx, which is 100x power 99, 100x power 99 plus cos x is always positive. Okay, therefore you can say the function is increasing in 0, 1. Okay, because 0, 1 x is positive. 0 to 57 degrees means 0 to 57 degree. I mean, I'm converting this 1 radian to degree. 1 radian to degree is 22 by 7. So you get 57 degrees. Okay. So 0 to 57 means first quadrant. In the first quadrant, obviously, what happens? Cos is positive. So positive number plus positive number will be positive. Therefore, the function is increasing in 0, 1. Okay. Now, the next one is show that the function f of x is equal to 2x plus pi by 4 is an increasing function on 3 pi by 8, 7 pi by 8. So what I do first, I find dy by dx. Now what is dy by dx? Is minus sine 2x plus pi by 4 into 2. Minus sine 2x plus pi by 4 into 2. I just differentiated this. Now my x lie between what? My x lie between 3 pi by 8 and 7 pi by 8. That's the interval given to me. So where will 2x lie? 2x will lie between 7 pi by 4 and 3 pi by 4. I am multiplying both sides by 2. Now I add pi by 4. So what is 2x plus pi by 4? 2x plus pi by 4 will be 7 pi by 4 plus pi by 4. This will be 3 pi by 4 plus pi by 4. So obviously this is pi less than 2x plus pi by 4 is less than 8 pi. This is 2 pi. So which quadrant is this? So when x belongs to 3 pi by 8, 7 pi by 8, my 2x plus pi by 4, belongs to what? Pi, 2 pi. Pi, 2 pi means third and fourth quadrant. In the third and fourth quadrant, what do you say about sine? Sine of 2x plus pi by 4 will obviously be negative. In the third and fourth quadrant, sine of 2x plus pi by 4 will be negative. So what do you say about dy by dx? Dy by dx is equal to minus 2 sine 2x plus pi by 4 will be positive. Why it is positive? You have a minus sign, minus into negative. Sine 2x plus pi by 4 is negative. Therefore, minus into minus is always positive. Therefore, you can say the function is increasing when 2x plus pi by 4 belongs to pi, 2 pi, or you can say when x belongs to 3 pi by 8, 7 pi by 8. Easy sum, isn't it? Now let's see the next problem. I have a similar question. Let's try this. So what is dy by dx? Dy by dx is equal to differentiation of sine will be cos 2x plus pi by 4 into 2. Now where does x belongs to? X lie between 3 pi by 8 and 5 pi by 8. Multiply both sides by 2. This is 5 pi by 4 and this is 3 pi by 4. Add pi by 4 to both sides. This is 5 pi by 4 plus pi by 4. And what about this? 3 pi by 4 plus pi by 4. Now 3 pi by 4 plus pi by 4 is pi, less than 2x plus pi by 4 is less than, what about the 6 pi by 4, which is 3 pi by 2. Therefore, when x belongs to 3 pi by 8, 5 pi by 8, my 2x plus pi by 4 will belong to what? It belongs to pi comma 3 pi by 2. What is pi comma 3 pi by 2? Third quadrant. In the third quadrant, what do you say about cos? Cos of 2x plus pi by 4 will definitely be negative. If it is negative, so what do you say about dy by dx? So my dy by dx is equal to 2 cos of 2x plus pi by 4 will definitely be negative because cos is negative. Therefore, you can say the function is decreasing. Where it is decreasing? When 2x plus pi by 4 belongs to pi comma 3 pi by 2, or you can say when x belongs to 3 pi by 8 comma 5 pi by 8. Very, very simple and straightforward problem. It's not difficult, but you have to think and do it. Okay, now this is again an NCERT question. Here it is not proving, you have to find the interval. How do you find the interval? It's a logarithmic function. So y equal to x by log x. So what is dy by dx? Dy by dx is, I am going to use quotient rule. When I do quotient rule, what do I get? I get log x the whole square. And I get log x. Here it is logarithm to the base e. And differentiation of x is 1. And then minus x into, what is differentiation of log x? 1 by x. Therefore, I get dy by dx is equal to log x minus 1 by log x the whole square. Now, as usual, what we do, we generally equate it to 0, right? I equate it to 0. I get log x is equal to 1 and x is equal to e. You know, log e base e is 1. This is actually base e. So, log e base e is 1, so x is equal to e. Now, what is the interval? The interval is 0 comma e and then, 0 comma e and then e comma infinity. Now, why did I start from 0? Because you know logarithmic function. Log x is defined only when x is positive. So, you cannot talk about negative values of x. So, it is only from 0 to e and then from e to infinity. Now, choose a number between 0 and e and see what happens. Dy by dx. Dy by dx will be, this is log x minus 1 divided by log of x the whole square. Okay. Now, 0 to e. Remember, e is from 2.7 something, and so on. E is a number like 2.732, something like that. Okay. So, I have to choose a number between 0 and 2. It's like choosing a number between 0 and 2.7. So, obviously, the choice is easy. You have to choose one. But remember, you can't choose one because log 1 is 0. So, denominator becomes 0. The function cannot exist. So, obviously, x is definitely cannot be 1. So, when you write this interval, you have to make sure you write 1. Okay, you have to remove 1. 0 to e excluding 1. You understand why now? Because log x, 1 by log x is not possible. Of course, log x is 1. But when you, log 1 is 0. But if the denominator is 0, the function is not defined. So, in this particular function, x cannot be 1. So, you have to remove that. Then what number will I choose? Obviously, choose 1 by e. 1 by e will be between 0 and e. So, what happens to dy by dx? Dy by dx will be log of 1 by e minus 1 by positive. Denominator is always positive. So, what is log 1 by e? It's log 1 minus log e by positive. Log 1 is always 0. Log e is 1. So, it is minus 2 by positive, which is obviously negative. Therefore, the function is strictly decreasing in 0 comma e. Correct? Log e is minus 1. Log e is 1. So, minus 1 is minus 2. Denominator is positive. So, negative by positive will be negative. Now, choose a number between e and infinity. I'll choose e square. Okay, e square will be beyond this. So, what is dy by dx? Dy by dx will be log of e square minus 1 by positive. But log of e square is nothing but 2 log e. But 2 log e is 2, which is obviously positive. Therefore, the function is increasing in e comma infinity. So this particular function is decreasing where? Is decreasing in 0 to e excluding 1, and it is increasing where? E to infinity. So very, very important that you know this difference. Okay, now I have to once again go to the proving sum. I have the function, I differentiate. What is differentiation of this? X minus 1 into e power x, I'm using product rule, plus e power x into differentiation of x minus 1 is 1. So when I simplify this, I get e power x common, I get x minus 1 plus 1, they get cancelled, you get x e power x. Now, e power x will never be 0 and it is always positive, correct? So x is greater than 0. So this is obviously greater than 0, correct? Therefore, the function is increasing when x is greater than 0. Again, I am repeating, e power x cannot be 0 and e power x is always greater than 0. X is greater than 0. So x into e power x is greater than 0. Therefore, the function is increasing. Okay. Now, this is very simple NCERT question. Y equal to log x. So what is dy by dx? Dy by dx is 1 by x, which is obviously positive for every x belongs to 0 to infinity. Why? X is positive. So numerator is positive, denominator is positive, therefore the fraction is positive. Therefore we can say the function is increasing in 0 comma infinity. Nothing is in that. And this is our last problem. Dy by dx is equal to e power 1 by x, and 1 by x differentiation is minus 1 by x square. Okay, and obviously x cannot be 0. It's already given in the question. But e power 1 by x will never be 0. And e power 1 by x is always positive. And 1 by x square is always positive, where it is square. So e power 1 by x is positive, 1 by x square is positive, with the minus sign it will be negative. Therefore, you can say the function is decreasing in R except 0.